Good morning, everyone. I think I can start class now. I have to remind you, we have some homework, some online homework this week. Let me see. We have table 6, table 7. Okay. Table 1 and table 2 is next week. And we have the interactive review. Okay, not interactive review in this week. We have only table 6 and table 7. I remember table 6 and table 7 this week. And we have one handling homework due next week on April 15th. That means the Friday next week we have 1 week to have this 1 week from now. The handling homework here. This homework is on chapter 10 is hypothesis testing. Please spend your time doing this to review all the materials in the chapter 10. And we only have one more chapter. We will not cover chapter 11. We will cover chapter 12 next week. Table 1 and table 2, and after that I will make the revision from chapter 4 to chapter 12, chapter 1 and 2 and 3, so you can do it. You can review by yourself because it's just conclude the concept about the statistics. I think you can read by yourself. And the final exam will be take place on. Okay, I remind you some event. The final exam will be on April 29. Okay, April 29. So I will give you. I will post the recent exams. Before I will post the recent exam on 4/2021. So for you to look at it and prepare for your final exam. And the contents about the final exam currently I don't know, but I will post on Canvas soon for you to look at it. Maybe next week I will post something for you to review, something for you to look at about the final exam. And we only have one more exam in the class. Exam 4 is on test 4. This will be on April 25 or April 22. So I'm not sure about this, so I will ask you because if you take the exam 4 on April 25, if you take the exam 4 on April 25, so it's on Monday, and after that you will have the final exam on Friday. Okay, so it will be very busy for you if you take the exam 4 on April 25. So I suggest if you can take the exam 4 on 22, so it's better. But I will give you the chance for this. Maybe if you prefer to take the exam 4 on 22, that's fine. Or if you take the exam on 25, it's fine for me. Okay, I will extend the day from 22 to 25 for you to take the exam, maybe. Okay. Any questions so far? Okay, that's all the information about the exam 4 and the final exam. And regarding the bonus point, I will think about it, and I will give you the bonus point in the exams, maybe exam 1, 2, 3, 4, but except the final exam. I cannot do anything with the final exam. If you get the lower score in the final exam, I cannot do anything. I cannot control the final exam, right? Because the final exam, I'm not the person who write the exam. It will be the another person. It's of the coordinator. I cannot do anything with the final exam. I only can control exam 1 to 4, 1, 2, 3, 4, something like this. I cannot control the final exam. So you have to review carefully about the material for preparation to the final exams. Okay, that's all the things about the final exam, something like this. Maybe the exam 1, 2, 3, 4 may be easier than the final exam, but the final exam will be more difficult. It's not more difficult, but it will be not easy like the exam in class. Okay. Okay, so now we will go to the chapter 10 review. Chapter 10 review, because this chapter will be it's very long, so I have to review for you in chapter 10. The concept about the hypothesis testing, I don't need to remind you. I just write down here for you to look at. We need to remember what is the hypothesis testing, what is the alternative hypothesis, what is no hypothesis. Okay, let me turn off the light here so you can look at this easier. You need to remember what is the no hypothesis and alternative hypothesis. Is it crucial, because when you do the exercise about hypothesis testing, you have to determine which is the alternative hypothesis, which is the no hypothesis. And the alternative hypothesis is the mathematical statement, like the mean will be greater than a number, the mean will be less than a number, the mean is different from the number, something like this. This is a mathematical statement that describes the population parameter. Population parameters. And the one thing in crucial here is the hypothesis that the researcher is aiming to gather evidence to support. That is important. Okay? That's the keyword. And the no hypothesis is opposite, is different from the alternative hypothesis. Okay, and it will always be statement of equality. For example, the no hypothesis should be mu is equal to the number, something like this. Mean have to be equal to some number or 2 or the population proportion will be 0.5, something like this. It's have the equal here. It will be always be statement of equality. Okay, that is the no hypothesis. And that's a concept about hypothesis testing. You can look at this about the level of significance, type 1 error and type 2 error. Type 1 error, that means you reject the true no hypothesis. That is a mistake. And the type 2 error, that means you failing to reject a false no hypothesis. Okay. And we have, in this chapter, we have 3 kinds. Let me see. Okay, we have 3 kinds of hypothesis testing. The first one is hypothesis testing for population needs or proportions. Okay. And hypothesis the chi-square distribution test for goodness of fit, or the chi-square test for association. Association, that means we will make the hypothesis testing about the relationship between 2 characteristics in the population. Okay. Something like this. Okay, I will move on to specific kind of testing. Let's talk about the hypothesis testing with population needs and proportion. Let's talk about this. We have 4 steps when we do the hypothesis testing here. I just summarize all the things about the hypothesis testing here. Okay, and we look at it. The first step here, we need to state the no and alternative hypothesis. That is the first step when you do the hypothesis testing about the population needs and proportion. And otherwise, the first step should be state the no and alternative hypothesis. And step 2, we will find the level of significance. It will give you the question will give you level of significance or level of confidence. So you need to find the level of significance. It's also in the question sometimes. And you have to compute the test statistic. The test statistic is used to make the decision. Okay. And how to calculate the test statistic? How to calculate it? It depends. It depends on the kind of the hypothesis testing you do. If the question asks you to make the hypothesis testing about the population means, the test statistic will be calculated by this formula. Otherwise, if it's asks you about the population proportion, the test statistic will be calculated by this formula. Okay. That is step 2. And step 3, we will find the p-value depend on the kind of test. Okay, I will remind you three kind of tests. Okay. We have X alpha here and X0, this is null hypothesis and alternative hypothesis like this. And the kind of test will be determined depend on the alternative hypothesis. If the alternative hypothesis either have the sign like this is greater than, that means the right tail test. Right tail test. If it is less than, it's the left tail test. And it's equal, that it's different, that's either two tail test. Okay. For example, maybe we have the like this, the proportion will be equal 0.2. X alpha here is different from 0.2. So could you tell me which kind of test here? Okay, Javier? Yeah, exactly, two-tail test. Okay. Okay, if the kind of test is two-tail test, so you can calculate the p-values by this formula. Okay? The p-value here is the probabilities of the z is less than the negative or absolute value of test statistic. Okay. To find this, you will use the table of normal distribution to find the probability here, and after that, you will get the p-value for this. Okay. And when you find the p-value, you will make a conclusion about the hypothesis. If the p-value is less than A here is the level of significance. A here is level of significance. Then you will reject the null hypothesis. If the p-value is greater than A, and that is level of significance, then you fail to reject the null hypothesis. Okay? And that is the step-by-step to do the hypothesis testing. So now I will give you the example for this. So you will look at the exercise 1 in your handout. Okay, look at the question 1. We'll give you the example. Question 1. Okay. So could you tell me, with the hypothesis testing here, they ask you to make the hypothesis testing about means, or they ask you to take the hypothesis testing about the proportion. Okay, Maria, please.
What did you mean?
Okay, mean, yeah, exactly. That's the ask you about the population mean, right? Any question? Okay. They ask you to make the hypothesis testing about the mean, right? Okay. So we have to analyze the questions. Analyzing the questions. So they give you mu here is 50, right? The standard deviation is 5. N here, okay, the N here is 123. Okay, the X bar here is 49. That is the sample mean. Okay, the significant alpha here is 0.05. Okay. First thing, when you look at this question, you have to write all information they give you. Okay, so now we go to the solving solution. Okay, how to do this? first step here. Step 1, you need to state the null and hypothesis testing. Okay, could you tell me what is null and what is the alternative hypothesis in this question? What is about the null and what is about the alternative hypothesis? Okay, Trivia. Sorry?
Equal to 49.
Is 49. Mean is okay. You mean the null hypothesis in mu is equal to 49?
Yeah, that's right.
Okay. Okay. Thank you. Okay. But any others? Any others answer? Okay, you Robin, right?
Yeah. The null hypothesis is equal to 50 degrees.
Yes. What about alternative? It opposite the.
Alternative is not 50 degrees.
Yeah, exactly. Okay. Okay. When you look at these questions, okay. Suppose has temperature changed in industrialization? Suppose that the mean temperature throughout history is 50 degrees, right? Okay, it's 50 degrees. That's in the null hypothesis, but because they want to check the statement, they want to confirm. They want to confirm this statement, right? They want to find the evidence gathered for this kind of statement. So that's in the null hypothesis. Okay, the null hypothesis. So null hypothesis mu here is 50, and the alternative is different from here. So it's 50 is different from 50 because you look at the question, you look at the statement. The temperature has been 49 degrees, right? Can we conclude that the temperature has changed since industrialization? Okay, that means this means mu here is not 50, is 49, is not 50. So mu here is different from 50. Okay? That is the alternative hypothesis. And this is step 1. Step 1 is to state the null and hypothesis testing. Okay. And step 2. Okay, step 2, you look at the slide here. Find the level of significance and compute that statistic. Okay, we have the level of significance here. We don't need to find it, right? We don't need to find it. The thing we need to find here is the population mean, right? Population means. The statistic for population means, right? Because the question is about the population mean, so we will use this formula. Okay, we will use this formula. Okay. We don't use this formula because it is about population proportion. In this case, the test statistic will be Z is calculated by x bar minus mu over sigma square root of n. So x bar here is 49 minus 50 over sigma here is 5 over square root of 122. Okay? And what about these values? This value should be okay. Let me check this. So this will be approximately to negative 2, right? Okay. You need to round it to 2 decimal places around. Okay. You need to do this. It's negative 2. Okay. This is Z value. Okay. That is we finish step 2, right? Step 2 we finish. Find the test statistic. Now we move on to step 3. Find the p values. P value. Okay, what the p value here? So could you tell me which kind of formula we use here? me see. Because we have to use this kind of formula, you have to look at what is the kind of test here. Two-tailed test, right-tailed test, or left-tailed test. Okay, Robin, please.
It's a two-tailed.
Okay, so you will use this formula, right?
Yeah.
Okay, thank you, Robin. Okay, so what form I have to write down here? So we use this formula, so it's 2 times the b value z less than the negative of absolute value of test statistic. So the test statistic here is negative 2 point. Okay, so negative of this one, right? So this one, the absolute value of the value, so it's exactly this value, right? Okay, for example, absolute value of negative 2 is exactly 2, right? So here, because the absolute value is positive, so I write down here is the 2.32. That's the b value. So we need to find the probability of z less than negative 2.22 by using the standard normal distribution table. Okay. So could you tell me what is the probability of this value by using the table? And that means you find this one. Could you tell me by using the table? Okay, Maria, please.
Would it be 0.0132?
Yeah, exactly. Thank you, Maria. So this is 2 times 0.0132. Okay. So the final answer should be equal to 0.0264. Okay. That's it about the p-values. Okay. So now we will move on to the final step. We will compare the p-value with the level of significance. In this case, we have two cases. The p-value is less than a, or the p-value is less than greater than a. So could you tell me which kind of case we have here? P-value less than a or p-value greater than a? We have p-value here and we have the level of significance here. So we need to compare this. Could you tell me which one? You please.
It's less than a, so we have to reject more.
Okay. Okay. What's your name, please?
Yeah.
Sriya. Okay. I remember Sriya. Because this value is less than the level of significance, so we reject the null hypothesis, right? That means we will not agree with the statement that the temperatures have changed, right? We will check this kind of the statement. The null hypothesis is the temperature is 50, right? The temperature is 50. So we reject that. We don't agree with this statement, right? We don't agree with this statement. Any questions so far? Okay. We finish this one. So the question two is similarly to question 1, but the question here is proportion, right? The hypothesis testing here is about the proportion. So the difference here is just the test statistic. The test statistic will not use this formula. They will use the formulas of the population proportion here. Okay? They will use this formula. And the step 1, 2, 1, 3, 4, so it's similar, it's the same. Okay? We don't need to care about this. So it's similar. You can do it by yourself. Now we move on to the section 3. Chi-square distribution test for the goodness of fit. Okay. Okay. The first step 1, we need to state the null and alternative hypothesis. Okay. The kind of the test here is the probabilities of the first outcome is equal to the probabilities. The second one is equal to the probability of k. And the alternative hypothesis, there is some difference among the probabilities. Okay, this is in the section 10 to 6. Okay, so for example, you can look at the question 3 here. You can look at the question 3 here. A school principal claims that the number of students who are taught in her school does not vary from month to month. Okay, does not vary from month to month. That means that the probabilities of students who are taught in the August is equal to the probabilities of students who are taught in September, equal to the probability of students who are taught in October, something like this. So the probabilities of here is equal together, equal. Okay, that is the null hypothesis. And the alternative hypothesis here is there is some difference amongst the probabilities. That means maybe B1 is different from B2, B2 is different from B3, something like that. That is the alternative hypothesis. Okay. That is example about the test of goodness of fit. Okay. And step 2, we need to determine the observed frequency. The observed frequency. For example, you can look at the question 3 here. We have the table here. We have the table here. We have the number here. This is the frequency. And this is on August, right? August. This is on September. Something like this. So the value is 7. The value is 18. So that means this is the O1. O1 is the observed frequency. Observed frequency are given in the table. The observed frequency are given in the table. But the expected frequency are different. You have to calculate it. The observed frequency is the practical aspect. The expected frequencies is the theoretical aspect. That is in theory. Expected frequency, that is theory. And observed frequency in practice. You can the observed frequency will be calculated, not calculated, will be found by using the table. That is the observed frequency. That is observed frequency. Okay. That's the O1. That's the O1. Then the expected frequency will be calculated by this formula. Okay. E1 equal E2 equal E3 equal EK equal to n times 1 plus over k. So here we have what is n here. The n here is the sum of these observed frequency. Okay, the sum of students here. Okay, you calculate the number of students here, the total number of students here, so you can find the value of n. And the k here is the number of possible outcomes. So we have August, we have September, we have October. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 possible outcomes, possible results. So that means we have k here is 10, right? That is the example. And we can calculate this formula. And after we determine the observed frequency and expected frequency, we can find the chi-square statistic by using this formula. And after that, we can find the number of degrees right here. And we make the conclusion depend on the relationship between the chi-statistic and chi-square critical value. How to find chi-square critical value? To find chi-square critical value, you will using the table I provided you in the previous handout, or you can use the textbook. Okay, it's on the page 816. 816, you can find the critical value of chi-square, right? And after that, you will make a conclusion Okay, that's all the step by step, all the steps to make a distribution test of goodness of fish. So now I will give you the example for this. How to do this? You can look at the question 3 here. Question 3. How to do this? I not here. I will give the step here. I will give step here for you to easy to follow. Move on to step 1. Step 1, we will state the null and hypothesis testing. Okay. Okay. So the null hypothesis should be the probability of students who are tardy in high school in August is equal to the probability of students who are tardy in high school in September. So that means the probability 1 is equal to probability 2, equal to probability 3, blah blah blah, is equal to probability 10. Right? We have 10 months here. August, September, October, November, December, January, February, March, August, May. We have 10 months here. So that is the null hypothesis. And the alternative hypothesis is there is some difference. Amongst these probabilities. That is step 1. Step 2. Step 2 here, so you can look at the step 2 determine the observed frequency and the expected frequency. As I mentioned you before, the observed frequency will be found in the table and the expected frequency will be calculated by this formula. So could you tell me what is the observed frequency here? O1 here is, okay, O1 here is 7, right? O1 here is 7. Look at it. And O2 here is 18. O3 here is 16. O4 here is 5. O5 here is 8. O6 here is 12. O7 is 7 or 15. O8 here is 18. O9 here is 12. Okay, 11, not 12. O10 here is 15. So we have all the information about observed frequencies. So how to calculate the expected frequency? The expected frequency will be equal together. E5, E6, E7, E8, E9, E10. And it's calculated by this formula. Okay. N over K, right? Is equal to N over K. So could you tell me what is N here and what is K here? Could you tell me what is the value of N here? The value of N will be found by the sum of these observed frequency. That means the number of students. Could you tell me what is the value of N here? What is the value of N here? Using calculators to find this. Okay, Mackenzie?
Is it 125?
Yeah, 125, exactly. Okay, so it's in 125. The K here is we have 10 possible months, right? 10 months. So K here is 10. Okay, so we find this in 12.5. That is expected frequency. Okay, that is step 2. Step 3, we will find a chi-square statistic. How to find this? We will use this formula, right? Chi-square statistic. We will calculate this formula. That means the sum of these, right? O1 minus E1 squared over E1 plus O2 minus E2 square over E2 plus blah 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 plus O10 minus E10 square over E10. Okay, this is very complicated calculation, so it's easy to make mistake in this step. Easy to make mistake in this step. So be careful. Be careful when you do this step. Relate to substitute all the value to this form. So it's very easy to make mistake here when you use the calculator. So the value, the answer for this, okay, I calculate it at home, and I get the result here is 15.56. Okay, that is chi-square. Okay. Just relate the value to this one. That is step 3. And step 4. The step 4 here, you need to find the level of significance and compute the number of degrees of freedom. Okay, what is the level of significance here? What is the level of significance here? The level of significance here is 0.05, right? And what is the degree here? The degree here is equal to k minus 1, and we have k here is 10, right? K here is 10. So 10 minus 1 is 9. So it's the degree. We finished step 4. Oh, no, we're not finished. No. We need to find the chi-square radical value by using the table sheet. So how to imply the chi-square radical value? So to find this, you need to find on the table the df here is 9. I'm going to find df is 9 here, and find the level of significance here is 0.05. So you make the intersection between them so you can find the critical value. So could you tell me what is the chi-square critical value here? Sriya, please.
16.919.
Exactly. Thank you. Exactly. That is the critical chi-square critical value is 16. So because you find this value here is 16.919. Okay, that is step 4. And step 5 here, we need to conclusion. If the chi-square statistic, okay, and I need to remove number 2 here. It doesn't make sense here. Don't have any number 2 here. Okay. You erase this. Don't have any number 2 here. Might be my typo mistake. Right? If the chi-square statistic is less than chi-square critical value, then we fail to reject the null hypothesis. If chi-square is greater than chi-square critical value, then we reject this. So could you tell me how we reject or we fail to reject here? Trivia? Okay, reject because the chi-square statistic is greater than chi-square test statistic. Okay, thank you. Trivia. Okay, so the step 5 is we reject this. Okay, because this value here is greater than this value. So we reject it. Any questions so far? Okay. We move on to the final one. The final one is the chi-square distribution test for association. It's used in when you want to make a hypothesis testing about the two traits, the two characteristics in the populations. For example, you can look at the handout, previous handout. You can look at the previous handout or this handout of 5. Okay. For example, we have the table. Let me erase it. For example, we have the table, a two-way table like this. So we have the admission status of student to West State University, admission status, something like this. And we have the row here. here is the male student. This is the male student, and this is the female student when they apply to university. And this is the status accept. This is the final deny. So we have 35, something 50, something like this, 25, something like this. So the question here is there any the admission status and the gender have some relationship? Okay. Now the question here is, are there any relationship between the gender and admission status? Or the question is, does the gender discrimination exist when they apply to the university? Something like this. That is the thing. When you use the chi-square distribution test for association, we will use it for test this kind of hypothesis. We use for this. Okay. The step one, when we do for this kind of test, here we need to state the no and alternative hypothesis. The no hypothesis here is the two variables in the population are independent. We have two variables here. The first variable is the admission status, and the second variable is the gender. The gender. We have two variables here. So the no hypothesis will be the relationship, the gender and the admission status in the population are independent. That means they are not related. Okay. Independent. Okay. And the alternative hypothesis is the two variables in the population are dependent or are not independent. Okay. So that means that we will have some relationship between the admission status and the gender here. That is the alternative hypothesis. Okay. That is step one. In step two, we will calculate the observed and expected count or frequency here by using this formula. And step three, we will calculate the chi-square statistic. It is similar to the chi-square distribution test for goodness of fit, but the difference here is the way to calculate the expected count, calculate the chi-square statistic, calculate the number of degrees here are different from the chi-square distribution test for goodness of fit. Okay. And when we find all the information here, we can make the conclusion about it. So step 5 is the same as the chi-square distribution test for goodness of fit. Okay, how to do this? We look at the question 4. That is the final question in the page 4. We can look at this and to show this. Question 4. Okay. Step 1. We will state known hypothesis. We have two x0 and x alpha. The x0 here, we have two variables here. That is the region of country. The west, the north, the south. That is the region of country. And we have the pursue and not pursue here. Okay. So the whole hypothesis would be the regions and the pursuit are independent, and the alternative is different, and this guy are dependent. Okay, that is the null and hypothesis testing. And that is step 1. Step 2. The step 2, we need to find the observed and expected count by using this formula. So I will draw the picture, well, I will draw the table for you to easy to calculate it. So we have the west here, the north here, have the sound here, and we have the pursuit here. So you look at this, how to calculate this, how to calculate this one, how to calculate the expected count for this one. So you will use this formula. It's a row total times the column total over the table total. Okay. So you look at this, the west, so you find the total here. So what is the total of west here? What is the total of west here? 140, right? So it's 140. And time to the total of pursuit here. So we find the total here. Okay. When you find the total here, so this means the value here is 100, and you over to 500 is total table. The total table is 500. So the value here is 28. 28. Similarly, you can find for the north, you can find to the south, find to this one. So you can do this. Okay. What is it? Maybe 46. I think so. 26. Let me see. 26 something like that. Okay, not sure about this, but you can use calculator. So this guy here is. Let me calculate it. It's a knot, right? So you find 230 times 100 over 500. So this guy will be calculated by, let me see, this guy times this guy. Okay, this guy 100 over 500. Okay. And this guy will be calculated by this number from this number over 500. This one, okay, and this one will be, okay, so if you calculate this by yourself, that is step 2. You will find the expected count by, you can list the table like this. This is step 2. And step 3, okay, the step 3 here, you need to find the chi-square statistic by using the formula here. So at the previous class, I mentioned you to make the table like this. Make the table like this. So it's the OI, this is the observed count, and this is expected count, and this column should be observed minus expected count, and this column is observed minus expected count square, and this one is observed minus expected count over expected count. So why I have to do this? When you make the table like this, so it is easy for you to make the calculation. It's avoid the mistake here. And one thing more here, you can make this one on Excel. When you do it on Excel, so it will avoid the mistake you make. Okay, you can do it on Excel. You draw the column like this, the row like this, so you can put on Excel. And after that, you will find the chi-square here. This is sum of these. It is sum of these columns. And this one here, I calculated here is this number. Okay. And that is step 3. And step 4, you will find compute the number of degree of freedom. Right? Then I will write step 4 here. Step 4 here is df is equal to the row minus 1 is times the column minus 1. Okay, we will count how many columns here and how many rows here. So we have 3 columns here and we have 2 rows here. So this is 2 minus 1 times 3 minus 1. So it is equal to. And final one, you will find the chi-square critical value by using the table. And the chi-square critical value here is equal to 5.99. And after that, you will compare this value, and you see that the chi-square statistic is greater than the chi-square critical value. And after that, you will make conclusion here is reject this null hypothesis. Okay. Okay, I will post the solution on Canvas for you to look at, because we have a lot of problems today. I will post the solution for you. Any question? No worries about it. I will post the solution. Let me make attendance. Samia here, Max here, right? Anna here, Lauren, Shay here, Kylie, Bobby, Christopher Dollar here, Shaylee, Mackenzie here, Robin here, Bennett Ross here, Abdul Hamid, Elizabeth here, Sherman John Peter, Kevlin, Liz here, James here, Delaney, Madeline, Adelia, Alondra, Mature here, Rick here,
Yes.
okay. Tyler, Alia Smith, Yassi, Sullivan, Maria here, Thomas, Priya here, Cameroon, Arthur, Tyler. Okay, thank you for your attention. Have a good day.